Alrighty, let's start right back where we left off. So if you recall, we had mentioned that I to the first power is I. I squared is -1. I cubed is -I. And I to the fourth is +1. And then after this, it just repeats. So the idea is that you want to turn these exponent numbers into powers of 4 times whatever it is to get that number. So for example, for I to the -29, you need to find a number that when added to either 1, 2, 3, or 4, you'd get -29. So in this case, the closest number to it would be our I to the -32, because 32 is divisible by 4. And so then to get back to that 29, we need to multiply by an I to the third power. So then that I to the -32 turns into 1, and the I cubed, like we said up here, is -I. So our answer for this one is just -I. And for this next one, so the closest multiple of 4 would be I to the 44, right? So that's divisible by 4. And then to get back to that 46, we need to multiply an I squared. And like you see, we have 46 I's total there. I to the 44, since it is a multiple of 4, would just go to 1. And then I squared, like we set up here, is -1. So that means our answer here is a -1. All right, now for the next one. It says, perform the indicated operations and write your answers in standard form A plus BI. So, what I like to think about in this case is treat your I somewhat how you would treat your X. So anything with an I here, for example, can be grouped together. And any constant number can be grouped together. So for this first one, we would get something like 5 plus 6, which is 11, and then a positive 2i minus a 5i would give you a -3i. And if you see, that is in the form a plus bi, with a being 11 and b being that -3. So for this next one, again, we notice that we have some i's and we have some constant numbers. For this one, however, I will say go ahead and simplify it out because of this minus sign here. So it'll look something like 2 minus 6i minus a -4i, which it would be a +4i, and then minus a positive 6i. Oh, sorry, there's no I here. That was just +4 minus 6i. So now from here we can see that there's 2 with i's and 2 numbers that are constant, and that will give us an answer of 2 plus 4, which is 6, and then a -6i minus a 6i will give you -12i. And again, that's in the form a plus bi. So for this next one, we're not adding or subtracting, we are multiplying. And in this case, you would FOIL it, similar to how you would FOIL a 2, similar to how you would FOIL if you had x's. So we would start with something like the first, correct? So then that would be 20. And then we go on the outside, plus 4i. Then we'll go on the inside, which is 7 times a -7 times 5, which would be -35, and then that I. And then we do the last terms. So you do a -7, and then I times I squared. Now we can simplify these because these two are common terms. And remember, this I squared here, like we said up here, is equal to a -1. So we are left with 20 plus 20 minus 31i, right? Because 4 minus 35 would give you 31, -31. and then minus a 7 times a negative 1, which that gives you a positive 7, and therefore you would end up with 20 plus 7, 27 minus 31i. All right, for this last one on this problem, I'm going to work it out on the side because it will be a little bit longer, but the idea is simple. You want to get rid of this I at the bottom, correct? So you can be left in the form of a plus bi. So in order to get rid of an I at the bottom, when you have something like a 3 minus I, you actually want to multiply by what's known as the complex conjugate, which is basically the same terms, but then with the opposite sign in the middle. And then you want to multiply the bottom by it as well, because this is 1, and therefore does not change the value of your expression. So when you multiply that across, right, we just FOIL the top, like how we did on C, and we'd have 4 times 3, 12, 3 times 3i, which is 9i, 4 times I, which is 4i, and this negative 3i times I, which is just positive 3i squared, all over this. So we FOIL this out the same way. That is 9, that is negative 3i, that is positive 3i, and the last terms would give you a negative I squared. So as we can see, the bottom, these terms will cancel out, and if we remember, I squared is just a negative 1. Same thing up here, I squared is just a negative 1. So when we simplify all of that, you'd be left with 12 plus, and we can combine these two terms, correct? 13i plus 3 times a negative 1, all over 9, and then those two go to 0, minus a negative 1. So then this here will be at the top 12 minus 3, which is just 9, plus that 13i, all over this 9 minus a negative 1, which is just 10. And then, since we want it in the form of a plus bi, you want to divide each of the terms at the top by the term at the bottom. And so you'll have an answer, something like 9 over 10 plus 13i over 10. And as you can see, that is an a plus bi form. All right, now for this next problem. Oh, sorry about that. Okay, this next problem says, solve the quadratic equation x squared minus 10x equals negative 9 by factoring and applying the zero product property. So if we want to factor, we want to start by moving our constant from the right side to the left side. So it'll look something like x squared minus 10x, and then if we add this 9 over to this side, we'd have plus 9 equals 0. So now we want to factor this to where we have two terms equal to 0 with an x in there. So the idea is you want to find two numbers that multiply to this last number, but those same numbers have to add to this number here. Correct? So two numbers that would multiply to a positive 9 would be 3 and 3, but if you add 3 and 3, you do not get negative 10. So let's try different numbers. What about a negative 9 and a negative 1? Negative 9 times negative 1 gives you a positive 9, and negative 9 plus a negative 1 gives you a negative 10. So those two will work, and we just plug those into there in our factored form. So now the zero product property states that if you have a number times a number and it has to equal 0, one or both of those numbers is 0. So it'll look something like x minus 9 is equal to 0 and x minus 1 is equal to 0. And then if you just simply work that out, you'll get x equals 9 and x equals 1. So your solution in this case is x is 9 and x is 1. And if you want to set that up in set notation here, you would say something like that, and that just means the solution set is 1 and 9. Alrighty, now for the next one. It says solve the quadratic equation x plus 1 squared equals 9 using the square root property. So the square root property states that if you take the square root of both sides, you'll be able to simplify something out. So in this case, since we have that squared there, we are just able to take the square root of this side, and then these two will essentially cancel each other out. So I'm going to work it out over here on the left. X plus 1 squared equals a positive 9. If we take the square root of both sides, like I said, these two will cancel, so you'd be left with just x plus 1 on this side. And then, luckily enough for us, 9 is a perfect square, so we'd get the positive and minus version of 3, so plus or minus 3. And then just to get x by itself on this left side, we are going to subtract 1, and you are left with x is 3 minus 1, or negative 3 minus 1. So that leaves our answers to x equals 2 and x equals negative 4, or like I said, if we want to put it in this solution set, we would say 2 and a negative 4 in these squiggly brackets. All right, now for number 16. Solve the quadratic equation x squared minus 6x plus 11 equals 0 by completing the square and applying the square root property. So, completing the square is a little tricky, so I'm going to work it out on this, on this right side. So, I'm going to start by writing down what we have. X squared minus 6x plus 11 equals 0. So the idea of completing the square is that you want to set up a quadratic equation that one side can be then simplified by the square root property like we talked in number 15. So the first step is to make sure that the coefficient in front of the x is a 1, which in our case it is, so we can move on. And then you want to move the constant number over to the side with no x's. So then it would look something like x squared minus 6x equals this negative 11. And as you can see, I left a little gap here because we are about to come up with a term there to be able to find a nice perfect square of the quadratic equation here. So if we remember, this term here is simply found by taking b over 2 squared. So in this case, our b is a negative 6, and if we take it over 2 squared, we'd have negative 3 squared, which is just a positive 9. So we have to make sure we add this to both sides so we don't change the value of the equation we're working with. All right, and now, as you can see, this x squared plus 9 is the same as saying x minus 3 times x minus 3 equals this negative 2 on this side. And this can simplify down to x minus 3 squared equals negative 2. And now we're left with something similar like how we had right here, where we can just take the square root of both sides. This will cancel. Now you will see we do have this negative here under the radical. And remember, this is the same as saying the square root of negative 1 times the square root of a positive 2. And we said the square root of a negative 1 is just I. So this actually simplifies down to I square root of 2. And don't forget it is plus or minus. And then we're left with x minus 3 on this side. So then now, if we move over this positive 3, we are left with a simple x equals 3 plus or minus I square root 2. Or if we want to do it in set notation, we would say 3 plus I square root 2 and 3 minus I square root 2. All in these squiggly brackets, and that is known as set notation. All right, for number 17, it says solve the quadratic equation by using the quadratic formula. So the quadratic equation here is in the form, I'm going to work it out on this right side, or on this left side. The quadratic equation that we want to get it to is in the form of ax squared plus bx plus c equals 0, or in this case, since we have y's, ay squared plus by plus c equals 0. Alrighty, so as you can see, we don't quite have it in that form, but you can get it to that form by simply moving this 2y squared over to this side, or you could have moved the 5y minus 1 over to the other side. Just get one side equal to 0. So now we are left with this 2. Now we are left with 0 equals positive 2y squared plus 5y minus 1. And if we recall, the quadratic equation, or the quadratic formula, is x is equal to opposite b plus or minus square root of b squared minus 4ac all over 2a. So if we start plugging things in, we know that this is our a, this is our b, and this is our c. So once we start plugging in, it will look something like x is equal to a negative b, which in our case is a 5, so a negative 5, plus or minus the square root of b squared, so 5 squared, minus 4 times our a, which is 2, times our c, which is a negative 1, all over 2 times our a, which we said was 2. Now, if you calculate this, you'd be left with negative 5 plus or minus under the radical, you'd be left with 33 all over the square root of 4. So now that we can leave that as our answer, or we can answer it in set notation over here, and that will just look like negative 5 plus square root 33 all over 4, or negative 5 minus square root 33 all over 4. All right, now for number 18, it says, for each of the following quadratic equations, evaluate the discriminant and determine the number and type of solution to each equation. So, if we remember, back to this quadratic formula here, the discriminant, it is this that is under the radical. Discriminant is what's under that radical. So, we want to find out what our discriminant for each of these is. So we want to test each of these out for the b squared minus 4ac and find out if it's 0, positive, or negative. Because depending on what you get, that will determine how many and what type of solutions you have for this problem. So we'll start with a. In a, it's simple. We can just see that our b in this case is negative 20. And then our a is 4, and our c is a positive 25. So this here gives you 0. So all of this is equal to 0. And what that means is that if you were to plug this 0 back into this equation here, you'd be left with a negative b plus or minus 0 over 2a. So that 0 would essentially go away, and you'd be just left with a negative b over 2a, which means we only have one real solution. So that is our answer for this. We have one real solution. All right, now for the next one, so that was A. Now for B, we're going to do the same thing. So we do b squared, which is our 7, minus 4 times our a, which is 5, times our c, which is negative 20. And then, once you do that, you should get 449, which is positive. So that means when you have it under the square root, you should get a real number. So this means, so if you get a positive number under the radical, it means that you will have 2 real solutions. So that means our answer for this B here is 2 real solutions. All right, now for C, if we have we do need to move this one around a little bit. So I'm going to write it out. Plus 5t equals 4t minus 11. So we want to get everything to one side and have something set to 0. So I'm going to move this 4t over and attach it to this 5t. So you'd have 5t squared plus t equals negative 11. And now you want to move this 11 over, so I'm going to add it to both sides. So now we have 5t squared plus t plus 11 equals 0. Now we should be able to plug into that b squared minus 4ac. So when we do b squared, in our case b is 1, minus 4 times a, which was our 5, and times c, which is a positive 11, you'll get an answer of negative 219. And when you get a negative number, this means you will still have 2 solutions, but you will have 2 non-real solutions. And if you think about it, when you plug this back under the radical, you'll have that square root of negative 1, which is I, correct? And so then that's what makes our solutions non-real. So the answer for this one is 2 non-real solutions. Alrighty, so now for this number 19, it is asking you to solve 0 equals a naught t squared plus v naught t plus s naught for t. So if we're trying to get just t, if you notice, this equation is in the same form as this equation here, correct? So I'm going to move our equation this equation here. I'm going to move it right here just so you can see that those two are indeed the same, right? We have the only difference is that we have t's instead of x's, but our a naught is essentially our a, our v naught is essentially our b, and our s naught is essentially our c. So to solve for t, very simply, we would just plug into our quadratic formula. And I'll rewrite it for you right here. Our quadratic formula, and in this case, we'll use t. If we want to solve for t, it'll be the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if we start plugging into this, it should be pretty straightforward. So if we know our b is that v naught, we'll have a negative b, so it has to be negative v naught, plus or minus that square root, again, of our b, which is v naught, squared, minus 4 times a, which in our case is a naught, times our c, which in this case is just s naught, all over 2 times our a, which is a naught. And I believe this is the simplest form of our t, so we can say that is our answer. All right, let's move right along to number 20. It says a rectangular piece of carpet covers 200 yards squared. The width of the carpet is 9 yards less than the length of the carpet. Find the length and width of the carpet. Round to the nearest tenth of a yard. So I always starting these problems by drawing a picture of what is seen. So for this problem, we have a piece of carpet in the shape of a rectangle, correct? And we know how much area this carpet covers. We know it's 200 yards squared, correct? Or square yards. Now, we don't know the width or the length, but we do know that this length and this width have a relationship. what we know is that the width of the carpet, so we know W is equal to 9 yards less than the length. So we know it technically is L minus 9, correct? So if you're trying to find the area of something, it's just A equals length times width. So in this case, we know length, we know L, it's just L, and then we know the width in terms of L is L minus 9. Now from this point, we can simply distribute this L into our equation, and we'd be left with something like, an area is 200. We'd be left with something like L squared minus 9L equals that 200. Now from here, you have options. You can either factor or complete the square or solve using the quadratic formula, because you do have just a squared term, a single term, and a constant term. So I'm going to be using the quadratic formula, which, if you remember from the last slide, we said that the quadratic formula is x is equal to negative plus or minus, or negative b plus or minus, the square root of b squared minus 4 times a times c all over that 2a. And in this case, we can say our x is actually our L. So we'd have L is equal, and I'm going to move this 200 over to get it in the form of ax squared minus bx minus c. So if we start plugging in what we know that the a here is just a 1, the b here is a negative 9, and the c here is a negative 200. So we have negative b, or a opposite of negative 9, which is just 9, plus or minus the square root of that b squared, so negative 9 squared, minus 4 times our a, which is 1, times our c, which is negative 200, all over this 2 times our a, which we said was 1. Now, if we do the math under the radical, we would get something like, we would get 9 plus or minus the square root of 881 all over 2. And the square root of 881 is roughly the same as, is roughly the same as 9 plus or minus 29.6816 all over, all over our 2. So it'll be something like 9 plus 29.681 over 2, and 9 minus 29.681 over 2. So this one here will give you an answer of 19 point, and since we want it in the nearest tenth of a yard, we have 19.3, or this one over here will give us a negative 10.3. Now, we do have two answers, and you might be wondering, well, which one do I pick? If you are talking in terms of lengths, widths, or times, you typically want to go for the positive answer. So in this case, we have 19.3. And what does that mean, going back to our problem? It is our length. So we know our length of this carpet is equal to 19.3 yards. And if we remember, our width is equal to our length minus 9. So that means our width is 10.3. And width is 10.3 yards. Alrighty, now on to number 21. It says, in a classic Seinfeld episode, Jerry tosses a loaf of bread, marble rye, straight upward to his friend George. who is leaning out of a third-story window. If the loaf of bread leaves Jerry's hand at a height of 1 meter with an initial velocity of 18 meters per second, use the model s equals negative 1/2 gt squared plus v naught t plus s naught to write an equation for the vertical position of the bread s in meters, t seconds after release. Then use the equation to determine how long it will take to reach George if he catches the bread on the way up at a height of 16 meters. Round to the nearest tenth of a second. So, it's a lot of words for one problem, but the essential idea is that you are given this equation here, and you are given some numbers, and you can technically find the vertical position s at a time t of this bread, correct? So, let's start off by talking about what each of these variables are. So g, in terms of this problem, is just gravity, which we know is 9.8 meters per second squared. And then this t is just some time. So all our t's are just some time. V naught here is our initial velocity. And S naught here is our initial height. So, knowing these four things, we are able to, I'm going to write on this left side, we're able to know, so we don't know what height we finished at, but we do know our gravity is this 9.8, and then we don't know t, but we do know our initial velocity, as it says right here, our initial velocity of 18 meters per second times that time t we don't know about yet, plus our initial height, which it says here that the bread of loaf leaves his hand at a height of 1 meter. So we know that the bread of loaf started at this height. So our S naught is just 1. So if we simplify this down, you will get something like S equals negative 4.9 t squared plus 18t plus 1. And that is what it wants for the first part of our question, which just says to write an equation. Now it says that we want to use this equation we came up with to determine how long, so we want to know time, it will take to reach George if he catches the bread on the way up at a height of 16 meters. So he caught the bread at a height of 16 meters. So now we technically know S, right? So if we know S is 16, and we know all of this information, plus 18t plus 1, and we want to know what t is, how would we go about solving that? Well, the easiest way is probably just to plug it back into the quadratic formula, which I am just going to copy from over here and bring it over here. So if we remember this quadratic formula, we can actually move, some stuff around on this equation here. So we can actually move this 16 over to this side and be left with something like 0 equals negative 4.9 t squared plus 18t minus 15. And now we have an A, a B, and a C that we can use to plug into this quadratic equation or quadratic formula. So now we know, and this is actually our t. So our negative b would be negative 18 plus or minus square root of b squared, which is just our 18 squared, minus 4 times our a, which is negative 4.9, times our c, which is negative 15, all over 2 times our negative 4.9. So whenever you do the math under the radical, you should get something along the lines of square root of 30, negative 18 plus or minus, all over this negative 9.8. So now you have the square root of 30, which is not a perfect square, but it is something along the lines of 5.4772. And if we were to break this up into our two answers, all over 9.8, we would get something along the lines of 1.3 seconds, or 2.4 seconds. So now you may be wondering, like how we talked about the last one, we don't have a negative. In this case, we choose the time that is the shortest. So, because that means if we were to draw this out in a graph, something like that, the first time that it reaches him is there. Technically, there will be a second time that it reaches him. And we want to know the first time, which is this 1.3. So our answer is 1.3 seconds. And if we want to answer this in a complete sentence, we would say something along the lines of, George will catch the loaf of bread 1.3 seconds after Jerry releases it. All right, now number 22 says solve the polynomial equation 4x cubed minus 6x squared minus 20x plus 30 equals 0. So there are some ways to solve polynomial equations. For this one, since we start with 4x cubed minus 6x squared minus 20x plus 30 equals 0, we can actually split this equation down the middle and treat these two as a group and these two as a group. So if we try to simplify this, we can actually pull out a 2x squared. So if we pull out a 2x squared, we'd be left with a 2x minus 3, correct? And then on this right side, if we notice, we can pull out a negative 10, and we'd be left with a positive 2x on the inside, minus 3, correct? If we were to FOIL this, we'd get this top number. So if we look at this, we have these two like terms on both of them. And it's essentially like if you had a number of like 2y minus 10y equals 0, you can group these two and then just attach the y. So 2 minus 10, and then attach the y, which would just be a negative 8y, correct? So similar idea for this problem. We would have our 2x squared minus 10 times that common term of 2x minus 3, and that all should equal 0. So from here, we have essentially factored it down, and we can set both of these terms equal to 0 by the zero product property. And 2x minus 3 equals 0. So this second one is a little simple. It'll just be add 3 over and then divide by our 2, so our x is 3/2. This top one, if we add our 10 over and then divide by 2, we'll have x squared equals 5. And then if we take the square root of both sides, we'll be left with x is plus or minus square root of 5. So now if we want to set this up in set notation, we can say our answer is 3/2 square root of 5 and negative square root of 5.
So now for this next problem, we want to solve the rational equation 4d over d minus 5 minus 1 over d plus 1 equals 3d squared plus 3 over d squared minus 4d minus 5. So my first step is going to be to go ahead and rewrite that by factoring out that part on the right side. So I'm going to say 4d over d minus 5 minus 1 over d plus 1 equals 3 d squared plus 3 over. Now if we notice the factors of factors of negative 5 are negative 1 and 5, or negative 5, positive 1. For this case, we want something that's going to add to negative 4. So we know that this is going to be what we're going to use. So 3d squared plus 3 over d minus 5, d plus 1. If we notice, those are the exact same factors, those are the exact same as our denominators on the left-hand side. So before we even go ahead and start, I'm going to say, okay, when will this not work? This is going to fail to work whenever we have division by 0. So I guess to prevent that from happening, let's say when is d minus 5 equal to 0, and when is d plus 1 equal to 0? Well, that's going to happen at negative 1 and 5. These are restricted. So we know already that if we get either of those numbers in our solution, that those are not going to be actual answers. Those are going to be restricted values. Yeah, okay. So next step here is I'm going to just make a common denominator between these two terms. So to do that, we want to have the same value in our denominator, right? So to get from, I guess, our common denominator is going to look sort of like this. So to get 4d over that, we want to multiply 4d over d minus 5 times d plus 1 over d plus 1, because this is just equal to 1, minus 1 over d plus 1 times d minus 5 over d minus 5 is equal to, same thing, 3d squared plus 3 over d plus 1 d minus 5. Awesome. So now our next step is going to be, I'm going to go ahead and FOIL this out, and go ahead and FOIL that out. So that way I have 4d squared plus 4d over d minus 5 d plus 1 minus d minus 5 over d minus 5 d plus 1 is equal to, again, this value, is equal to this value Now, combining these fractions on the left-hand side, I'm going to have 4d squared plus 4d minus the quantity d minus 5 over d minus 5 d plus 1 equals the right side again. And so now this here is going to turn into 4d squared plus 3d plus 5 over d minus 5 d plus 1 equals 3d squared plus 3 over d minus 5 d plus 1. Now, we have, if we notice, the denominators on both sides are the same, so go ahead and multiply that through by d minus 5, d plus 1. That's going to cancel out this term is going to go away. So we just have 4d squared plus 3d plus 5 equals 3d squared plus 3. We want to subtract a 3d squared term from each side. We want to subtract a 3. So that we end up with 4d squared minus 3d squared is just d squared plus 3d plus 2 is equal to 0. Now we can factor this. Two numbers that multiply to 2 and add to 3 are 2 and 1. So our solution is going to be d plus 1, d plus 2 is equal to 0, which gives the solution set -2, -1. Now, if you'll remember from earlier, we already said -1 was not a possible solution. That was a restricted value. So that is going to be removed from our solution set. What we're going to end up with is d equals -2. Perfect. Awesome. So now our next problem, over here we have solve the following radical equations for number 24a. And my first step would be to go ahead and add 3 to both sides. So we have 2 root 3m plus 4 equals 8. Go ahead and divide by 2. And now we have root 3m plus 4 equals 4. From there, go ahead and square everything to get rid of that square root. So we have 3m plus 4 equals 16. Go ahead and subtract our 4. 3m equals 12. And then m equals 4. From there, now for this next one, we want to go ahead and solve for x. So I guess what I'm going to do first is I'm going to go ahead and subtract a 4 over, minus 4. That's going to give us the square root, 51 minus 14x equals x minus 6. Now again, to get rid of that square root, we want to square everything. So on the left-hand side, it'll be nice and easy, 51 minus 14x. The right-hand side, though, we're going to have to FOIL that out. So we have x minus 6, x minus 6. Our first term is going to be x squared. Inside is our minus 6x. Outside, again, is minus 6x. And the last term is 36. So that will give us 51 minus 14x equals x squared minus 12x plus 36. Just to get everything on one side, go ahead and add 14x, subtract 51, which will get us x squared plus 2x minus 15 is equal to 0. Two numbers that multiply to -15 and add to 2 are going to be +5, and -3, which gives us the solution set -5, 3. So let's go ahead and put that down. Now something we do need to make sure of, though, is that our answer that we found works with our problem. So what we want to do is plug in both of these values and just make sure that neither of those will break essentially the equation that we have. So I'm going to use that -5 first. We have root 51 minus 14 times -5. That's really the big part where things are going to break. We don't really have any other place where we could take square root of a negative number or divide by 0. So this will be the same as root 51 plus 70, which is the square root of positive 121. So that one is okay. And then we also want to check our positive 3. So we'll have 51 minus 14 times 3. That's equal to 51 minus 42, which is the square root of positive 9. And that one is also okay. So we're good to go. Now for this next one, it's going to get a little tricky, so bear with me. But my first step is going to be to square everything in the equation. Just to get rid of those square roots that the x's are trapped in. So the left-hand side is going to be nice and easy. It's just going to look like x minus 2. The right-hand side is going to be a little bit more complicated. can have root 2x plus 3 minus 2, whole thing is squared. That's the same as saying this, right? So we're going to have to FOIL this. First term times first term, that is going to be, let me write this over here. First term, that's going to be 2x plus 3. Outside, minus 2 square root of 2x plus 3. Inside, minus 2 square root 2x minus 3 plus 3. And then last will just be plus 4. So all in all, we're going to have x minus 2 equals, go ahead and combine these two, 2x plus 7 minus 4 square root of 2x plus 3. I'll go ahead and add this over, and then subtract the x minus 2 from both sides. So that will have 4 square root of 2x plus 3 is equal to 2x minus x is x, 7 minus negative 2 is positive 9, and then we'll want to square it again. We'll end up with 16 times 2x plus 3 is equal to the quantity x plus 9 squared. Same as saying x plus 9 times x plus 9. Go ahead and FOIL that. So that'll be x squared plus 9x plus 9x plus 81, or x squared plus 18x plus 81. And then distributing this, we'll say that's equal to 32x plus 48. Now subtracting that over, minus 32x minus 48 minus 32x minus 48 will give us x squared minus 14x plus 33 is equal to 0. Two numbers that multiply to 33 and add to negative 14 are going to be x minus 11, x minus 3 is equal to 0. So that our solution set is going to be 3 and 11. Okay, so now for problem 26a, we want to make an appropriate substitution to solve the following quadratic-like equations. So I guess the substitution I'm going to make for this one is, let's sub out this 3x plus 7. Just say u equals 3x plus 7. I guess how does that impact our formula? This is going to become a u squared. This is going to become u. So we'll have u squared minus 6u minus 16 is equal to 0. Now, two numbers that multiply to negative 16 and add to negative 6 are going to be x minus 8, or sorry, u minus 8. Let me fix that. U plus 2, which gives us a solution set of negative 2 and positive 8. But we're not done here. We have values for u. We need to convert those into values of x. So we want to set each of those equal to our 3x plus 7. 8 equals 3x plus 7. So we subtract 7 everywhere. We end up with 3x equals negative 9, and 3x equals 1. That will give us solutions of negative 3 and positive 1/3, which is going to go right here. So now, for this next problem, we have y to the 1/2 minus y to the 1/4 minus 6 is equal to 0. Something I'm going to point out here is that y to the 1/2 is the same as y to the 1/4 squared minus y to the 1/4 minus 6 is equal to 0. So this works because if we multiply 1/4 by 2 up here, we'll get 1/2. So basically we're just kind of rewriting it to find where our square is hiding. Here I'm going to make the substitution u equals y to the 1/4. So this is going to become u squared, this is going to be u squared minus u minus 6 is equal to 0. Now two numbers that multiply to -6 and add to -1 are -3, positive 2. So we're going to say u minus 3 times u plus 2 is equal to 0, which gives us solutions of -2, positive 3. Now again, we're not done. What we have to do is kind of take these values and convert them back into y's. So we could write -2 equals y to the 1/4, and 3 equals y to the 1/4. Go ahead and solve this one first. Just raise everything to the 4th power. Say 81 is equal to y. This one over here, though, notice how we have that negative there. Here in front of the y to the 1/4, we don't really have a negative or a positive. It just is a normal y to the 4th, right? So what we need to make sure of is check whether or not this will actually yield a proper solution. So raise everything to the 4th. We get y equals 16. Plugging that back in, we'll get 16 to the 1/2 minus 16 to the 1/4 minus 6. Now 16 to the 1/2, that's 4. 16 to the 1/4 is 2 minus 6. 4 minus 2 is 2, minus 6 is -4, which is not equal to 0. So this is not a solution, which just leaves us with y equals 81. And that is our answer.